Well, it's my privilege to be here with you again today, and I must also say I'm very thankful to be at a conference where the authority of God's Word is proclaimed so firmly and so often. Oftentimes when I speak places, that's not necessarily the case, and so a creation speaker would typically have to spend some time even talking about what inerrancy means and why it's important, and I'm thankful that that's not necessary here, that foundation is being laid as well as it is, and so that gives me the opportunity to explore some other topics that necessarily wouldn't have always time for. And that's proclaiming the Lord's glory through that which he has made. As you can see, our title for this session is called Our Created Solar System. We're going to dig deeply into the topic of the solar system that our planet is found within and see what it can tell us about the origins issue. Does it look like the product of natural processes, just the laws of physics working themselves out over billions of years? Or does it look like something that was created? So before we can do that, I suppose we should define what the solar system is. So the Latin name for the sun is Sol. Thus, this is the solar system, meaning the sun and everything that revolves around it, and so on. So there's a number of planets here. But this diagram that I'm showing you is to scale in terms of size. So the sun is really that big compared to the Earth. Oops, this one. And relative to the planets. This is not to scale for distances, though. In the real solar system, everything is much farther away from each other than shown here. But the planets of our solar system are shown here in proper order and closest to the sun. So the closest one is Mercury, almost the size of my laser dot there. Then there's Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto got demoted, so it's not in this list anymore. It's down here with the dwarf planets, or planetoids, or plutoids, or whatever you want to call them. We'll be talking about each of these a bit here in our time. Now, the Bible says, in Genesis 1, that in the beginning God created the heaven and the earth. Hopefully that's a familiar verse to us. Further on in Genesis, it says, "And God said, let there be lights in the firmament of the heaven to divide the day from the night. And let them be for signs, and for seasons, and for days and years. And God made two great lights, the greater light to rule the day, and the lesser light to rule the night. And he made the stars also." So this is telling us that the Lord made the celestial bodies as part of this creation process during creation week. Of course, this is not what we will be told in our culture today. Our culture today proclaims a secular model as being true. And the most popular, by far, secular model today, it really doesn't have any competition anymore, is called the solar nebula model. Now, as you might guess by the name, solar means something to do with the sun. Nebula means a big cloud of gas. So this model says that our entire solar system came from a large cloud of gas about 4.5 billion years ago. So the story goes like this. In the beginning, there was gas. That gas then began to collapse under the force of gravity and swirl around. As it did so, little grains of dust began to condense in the gas. Those grains of dust began to stick together to form little rocks. The little rocks then stuck together to become bigger rocks. The bigger rocks stuck together to become what are called planetesimals, which means asteroids, basically. The word means little planets. And then the planetesimals, the asteroids, stuck together in various ways to form the planets that we see in our solar system today. Now, if you look at the textbooks or the science programs or a planetarium show or whatever, you will be told that this is good science, that this is where the solar system came from. Minor detail, though, that they often leave out, in fact, they always leave out, as every time I've seen, is that this model doesn't actually work. Why is that? Well, there's problems, first of all, getting dust from the gas, but let's give them that for the moment. Let's say you get the dust. Once you have dust, do particles of dust stick together? Well, sure, just look under your furniture for proof of that, right? And once you have the clumps can stick together. Okay. But once the material gets about this big, 1 meter or less, that's where the accretion, the building process, stops. Why is that? Because when you get rocks this big, they now have enough mass to start breaking each other apart as they collide. I mean, what happens when you ram rocks together this big at hundreds of thousands of miles an hour? Do you get bigger rocks out of that process? No, you get rubble, right? So at this big, they're big enough to be destructive, but they're not yet massive enough. They don't yet have enough mass to have enough gravity to pull the pieces back together and build bigger things. So the planet building process stops right about this size. And some of the secular authors will even admit this. One of my astrophysics textbooks points out, once these planetesimals, these asteroids, have been formed, further growth of planets may occur through their gravitational accretion, the gathering together, into larger bodies, But just how that takes place is not understood. This author said the formation of planetesimals, the kilometer-sized planetary precursors, is still a puzzling process. This author says how the first stage of this process, primary accretion, works is a fundamental unsolved problem of planetary science. Now, those of you who like astronomy and like to consume science media, who heard about this problem the last science program or planetarium show you went to? Did they talk about this part of the model? Or did they just say, oh no, we have it all figured out, good science, gas, rocks, planets, here we are? Well, that latter story is what's usually given. Now, of course, the secular scientists are well aware of this problem, and they claim to have a solution for it. This is their solution. See if you think this is a good scientific model. Objects must have grown very rapidly from sub-meter-sized pebbles into 100-kilometer-sized bodies, possibly in a single leap. In other words, the physics says you can't make things bigger than this. Well, no problem. We'll just say that in our model, things this big, rocks this big, turned into asteroids the size of Rhode Island. Is that a scientific model? Or is that an excuse? That's just a bunch of hand-waving, right? Well, it must have happened somehow because we're here, aren't we? You ever talk to an atheist and hear that little line, by the way? Not a logical fallacy there, right? And just as a by the way, if someone ever uses that line on you, say, I can use that logic too. I can prove we're created because we're here, aren't we? If it works for you, it works for me, which means it doesn't work for anybody. That's bad logic, isn't it? Okay, onward. So we can actually stop our conversation right here because the secular astronomer doesn't have the building blocks he needs to make anything in his solar system model. He can't get rocks bigger than about this. But let's move on anyway. It turns out even if you give them the rocks they need, they still can't account for the things in our solar system. So that's what we'll spend the rest of our time on here this afternoon. We're going to go through each of these planets and show how each of them actually discredits the secular model in a different way, which I think is a lot of fun that the Lord made things to do that. So again, we have Mercury, Venus, Earth, Mars. These 4 planets here are sometimes called the terrestrial planets. Now, the Latin word for Earth, the Latin name for Earth, is terra. Thus, since all these other planets are rocky like Earth is, we call them the terrestrial planets, just as a way to categorize them. And the smallest planet, of course, is the planet Mercury. That's where we will start our little tour of the solar system here. Now, Mercury is a tiny little planet. It's actually smaller than some of the moons elsewhere in the solar system. As such a small object, then, the model has certain predictions about what Mercury should be like. Turns out Mercury isn't actually the way it's supposed to be, though. For one thing, Mercury turns out to be very dense. It's so dense, in fact, that it's estimated that about 3/4 of its interior volume is occupied by an iron core. Now, of course, we've never actually been inside the planet to see what's there, but we have orbited it with spacecraft, and we've measured its gravitational pull on our spacecraft, and we can look and see how big it is just by looking at it. So if you know how big it is and you know how much gravity, therefore how much mass there is, you can calculate its density. So Mercury is so dense that it has to be mostly just a big ball of iron with a little layer of rock on top. And that's interesting because the secular model can't accommodate Mercury being this dense. It can't be this dense according to the model, but it is. Well, this creates a problem. Where there's a problem, you need a solution. So if you look in the textbooks and whatever, you'll be told, well, Mercury formed less dense as the model predicts, and then an asteroid crashed into it early in its history and broke it up into pieces. And the less dense pieces wandered off into space after the collision, never to return, leaving behind only the really dense stuff that then reformed into a planet today. So that's their solution, but where's the evidence for this collision having happened? Well, the evidence is that if it didn't happen, Mercury would discredit the secular model. Now, is that good evidence? Is that actually scientific evidence? Well, no. That's letting you're putting your cart before your horse, right? Moreover, there's scientific evidence against this collision having happened. For example, had this collision happened, well, it would have been very violent, but been a lot of heat, and volatile elements like sulfur would have vaporized in this collision. So whatever sulfur was there before the collision wouldn't be there afterward because it would have gone away. Yet, Mercury's surface has a lot of sulfur on it, and potassium and other things that shouldn't be there if this collision had happened. Oh, and by the way, the secular model says sulfur can't have gotten there in the first place anyhow because sulfur couldn't have condensed out of that cloud in Mercury's neighborhood. So the secular model says Mercury can't have had sulfur on it to begin with, And even if it did have some to begin with, it couldn't have survived the collision. Yet, as I said, there's lots of sulfur on the surface today. So Mercury doesn't fit their model. There's more we could say about Mercury, actually, if we had the time to do so, but for our time here today, let's move on and talk briefly about Venus. Now, Venus is an interesting place. Its surface, for example, is very young. It doesn't look 4.5 billion years old. It looks like the whole planetary surface was resurfaced quite recently. Now, by resurfacing, I mean either it was formed recently or it somehow resurfaced itself recently. Either way, it doesn't look billions of years old. Now, if you want to believe in the billions of years, though, you have to come up with the reason why a planet would resurface itself for with no apparent stimulus to do so. So that's an interesting challenge if you want to believe in the billions of years. Moreover, Venus also doesn't have a moon. Now, remember, Venus is Earth's neighbor in space. It's sometimes called our sister planet because it's about the same size and the same mass and the same location. Now, if you want to believe in the secular model and you want to deny a creator, then you believe that these things formed by the laws of physics on their own. So if something formed at the same time in the same place from the same materials by the same natural processes, you would expect these things to have roughly the same major characteristics then. And since the Earth has a moon, then Venus should too. But Venus doesn't have a moon. Well, this is a bit of a problem if you're a secular modeler, and if there's a problem, you need a solution. Well, the solution is that Venus did form with the moon, as the secular model would sort of imply, but then an asteroid came along and smashed into it and destroyed it. Well, where's the evidence for the collision? Well, the fact that the moon isn't there anymore. There's more we could say about Venus, but let's move on here and talk briefly about Earth. Now, we could do a whole session on just how amazing the Earth is. And actually, I'll be talking, some of the same material I'll be talking again about tomorrow in my session on the Goldilocks cosmos. But the Earth is really uniquely designed for life. Here's a few examples of what I'm talking about. Our rotation period is 24 hours. That's what gives us the length of our day. Now, who woke up this morning thanking the Lord that he made the day 24 hours long? Probably nobody, right? We just take that for granted. I mean, the sun goes up and it goes down, and we go on with our business. At least it goes up and comes down here. I mean, I live in Seattle, so I don't get to see that thing very much. But anyway, I'm told that it comes up every day. But 24 hours, we just take that for granted, right? Turns out 24 hours is just right to sustain life here on Earth. If the Earth rotated more quickly, then we would start to have violent winds on the surface. That makes things a little less comfortable for us here, doesn't it? Conversely, if the Earth rotated more slowly, then any given spot on the Earth's surface would be exposed to sunlight longer and get hotter, and then be away from the sun on the night side for longer and then get colder, so there'd be much more violent temperature swings. 24 hours turns out to be just right. And it's not like 24 hours is some kind of preordained thing for a planet to have. Elsewhere in the solar system, we see like the planet Jupiter has a 10-hour day. Imagine how big that planet is screaming around its axis once in just 10 hours. Conversely, Venus's day is 243 Earth days long. So, I mean, those are your options, that span. But we're right at 24 hours, which again is just right. Our axial tilt, 23.5 degrees, gives us moderate seasons. Again, that's not a preordained thing either. Mercury, for example, has almost no axial tilt, so it has no seasons whatsoever. On the other hand, Uranus has a 97.8 degree axial tilt. It's actually way over on its side. So for half of its year, one half is always pointing, and the other half the opposite pole. Well, not a full half of the year, but you understand what I'm saying. Sometimes of the year, it's the pole pointing at the sun, and then it goes all the way around toward the opposite pole. So imagine how wildly variant seasons would be if our planet was like that, but it's not. 23.5 gives us nice seasons year-round. Our orbit is nice and circular. Again, gives us a moderate climate. Again, we take that for granted, but that's not preordained either. For example, Mercury has a more eccentric, a more oval-shaped orbit. It actually receives twice as much radiation from the sun at its closest point compared to its farthest point. Imagine if every year the amount of energy we got from the sun varied by a factor of 2. What would life be like here? I mean, this would be bad, but we don't have that problem because it's just right. Our atmosphere. This is a photo from space. You see our atmosphere isn't very thick. I mean, if you could drive at highway speed straight up, you'd be in space in about an hour, which is really pretty scary if you think about it. Space is a very hostile environment. It's actually a lot closer to us than we commonly think. But yet our atmosphere is just right to protect us. It gives us air to breathe and protects us from harmful radiation. At the same time, it's not too thick. What do I mean by that? Well, an example of having an atmosphere that's too thick is Venus's. Venus's atmosphere is thicker than ours and causes a runaway greenhouse effect where solar radiation is trapped beneath the atmosphere. And as a result, Venus, if any place on the solar system qualifies as being hellish, it would be Venus. Atmospheric pressure there is 92 times that on Earth, despite being a planet roughly the same size and mass as ours. Surface temperature is almost 900 degrees Fahrenheit, hot enough to melt lead on the surface of Venus. Not because it's too close to the sun. I mean, Venus is hotter than Mercury because of this greenhouse effect. But we don't have the risk of a greenhouse effect because our atmosphere is just right. Now, there's a lot of other things I'll be talking about tomorrow in terms of fine-tuning of the Earth and so on, but question for now, does this look like the product of random processes? Or does it look like the Earth was designed? No, I argue that it is indeed designed for us to be here. But as Christians, this shouldn't surprise us, right? Because what does Isaiah 45 say? Thus say, it says, "Thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it and created it not in vain." He had a purpose, which was what? He formed it to be inhabited. So if an omniscient, omnipotent, benevolent creator made the earth as a nice place to live, and then we shouldn't be surprised that that's exactly what it is. Other things we could talk about the Earth. About 70% of the Earth's surface is covered with water. Well, that's interesting because the solar nebula model says there shouldn't be any water on Earth. Did you know that? The Earth is bone dry according to that secular model of gas and so on. But of course, that's not what we see. So where did all the water come from? Well, the secular modelers used to say that all of our water came from comets. They said, yes, the Earth formed dry, like the model says, and then afterward, hundreds of millions of comets came in from elsewhere and bombarded our planet, and that's where our water came from. Now, it's true that comets are made of snow and ices, I should say. They're basically dirty snowballs. But the problem is we have really been studying comets fairly intensively recently, and in some cases actually taking samples of them and bringing them back for study. Turns out cometary water has some important chemical differences with Earth's ocean water. Specifically, the deuterium ratio is different. That means Earth's water could not have come from comets, which means the secular model says Earth doesn't have any water. Of course, the Earth does have water. Well, this creates a problem, doesn't it? Well, there's a problem, you need a solution. So the official solution now is that Earth was bombarded not with comets, but with asteroids. How much water does an asteroid have, though? Not a whole lot. Now, some categories of asteroids do have slightly more water than others, but it turns out their water has some important chemical differences too. So this isn't a good solution either, yet it's still being promoted today because it's really the only option they have. Moving on, we'll talk briefly about our moon. Now, there's lots of people who talk about design of the Earth, but not a whole lot of people talk about our moon as evidence for intelligent design. But it actually is. For example, the moon is of the appropriate size and mass and distance from Earth to raise tides of a good size in the Earth's oceans. What do I mean by good size? Well, if the moon were farther away or smaller, then the tides would be smaller, and Earth's ocean waters would run the risk of becoming stagnant. And stagnant oceans means things starts to die, which affects the whole food chain, including us. Conversely, if the moon were larger or closer to us, we'd start to have more violent tides, more destructive to Earth's coastlines. Yet the tides that we have are just right. The moon's also uniquely positioned. The moon's about 400 times smaller than the sun is, but it's 400 times closer to us than the sun is. And its orbit is aligned in such a way that at regular intervals, the moon will go just in between the Earth and the sun in such a way that it'll exactly blot out the disk of the sun for observers on Earth's surface. We just had a total solar eclipse in the U.S. last year. I don't know if anybody had the chance to get down to see it. There's another one coming to North America in a couple more years, which it's worth the trip. I mean, I don't think it'll come this far north, but wherever it comes in the U.S., go down to see it because it's worth the experience. It's amazing. Every time, and people go all over the world to see these things when they happen, including cruise ships in the middle of the Pacific Ocean, and because these are amazing events. Anyway, sales pitch over. Something that's not commonly talked about, though, well, a couple things. First of all, this enables us to do some good science, because this blocks out the direct sunlight from the sun's disk, where we can still see the corona. Now, normally we can't see the corona because the sunlight overwhelms it. So this allows us to do some good science, first of all. Second of all, it really is an amazing coincidence, though, that this even happens at all. What do I mean by that? Well, the last I checked, there was over 163 moons throughout the solar system. Now, of these 163 moons, how many of them have the proper combination of size, distance from the planet, and distance from the sun and so on, to just exactly blot out the solar disk for an observer on the surface? 1. Ours. As an astronomer friend of mine points out, it's an amazing coincidence, tongue-in-cheek, he's a Christian, it's an amazing coincidence that the only place in the entire solar system where these types of things are visible is also the only place in the entire solar system where there's observers to observe them. I think this is great support for the Lord creating these objects to be signs and seasons for us. Moreover, the moon also, it turns out, stabilizes the spin of the Earth on its axis and our axial tilt. Now, obviously, I don't accept the whole millions of years, billions of years way of looking at things, but even those who do accept that way of looking at things have to wrestle with the fact that the moon stabilizes the Earth over these long periods of time. As this author says, Earth's obliquity would vary chaotically from 0 to 85 degrees on a time scale of tens of millions of years, were it not for the presence of the moon. Earth's climatic stability is dependent to a large extent on the existence of the moon. So what would happen to Earth's climate if, as the years went by, our axis was doing this relative to the sun, and also precessing like this? I mean, the climate here would go haywire, right? But we're not expecting it to do that over long periods of time because of the moon. Now, again, I don't accept the millions of years that goes into this calculation, but I think it's interesting that the Lord created things in such a way that even if you do want to buy into the billions and millions of years, you still have to wrestle with this kind of issue. Moon's also unique in that it's the only other celestial body other than Earth that people have gone and walked on. Now, there's several reasons that we went and walked on it. First was to beat the Russians. Second of all was to answer the question of where did this thing come from? Now, of course, the Bible tells us where it came from, but unfortunately, the secular scientific community has rejected the Bible, so they try finding other answers. And at the time of the Apollo program, there were 3 competing secular models for where the moon came from: the fission theory, the nebula theory, and the capture theory. And I'm not going to bother explaining details because the Apollo astronauts brought back hundreds of pounds of samples with them, moon rocks and lunar soil, and it turns out the samples, for various reasons, disproved all 3 secular theories. So for a time in the 70s, secular scientists had no feasible model for where the moon came from, other than the Bible, which they reject. Well, this creates a problem, doesn't it? And when there's a problem, you need a solution. So the solution today is that this Mars-sized asteroid came cruising along early on in the solar system's history and smashed into the Earth. The debris went up into space, some of it came back down, but the rest of it stayed up there and formed our moon, which is up there today. Now, if you look in the textbooks or the science programs or the planetarium shows, you'll be told that we know this is what happened. Actually, we don't know that this is what happened. In fact, for several years now, we've known that it couldn't have happened, yet they're still teaching it anyway. How do we know it couldn't have happened? Well, because I told you that the astronauts brought back rocks and soil samples. This is Apollo 17 astronaut Harrison Schmitt, who's actually a PhD geologist, taking some soil samples. And a few years back, early 2000s, some scientists said, you know, back in the 70s when we analyzed all this stuff that they brought back, our lab gear wasn't as good as it is today. We got better equipment now. Maybe they missed something back then. Let's go back and look at it again. Sure enough, turns out that some of the soil samples contained volcanic glasses which have traces of water in them. Now, not much water. That's why they missed it the first time they looked for it in the 70s. But now we know there is water in this. Now, why is this important? Well, water in the soil overall isn't that big of a deal because that could have come from meteorites or comets or whatever after the moon was formed. But if the water's inside the volcanic glasses, well, the volcanic glasses came from where? Inside the moon. That tells you there's water down there inside the moon. But, big problem. If this collision had happened, this would have been violent enough to vaporize any water that was in this impactor body. Thus, there wouldn't be any water at all in the material that gathered itself together again afterward. Yet there is water there, which means this never happened. But they're still teaching this as fact today. Why is that? Because they have no alternative to offer. which I do not think is good science education, but there it is. Another question with the moon, how old is it? It's supposedly been there, according to the secular model, 4 billion years or so. And this is another thing that the astronauts went up there to help shed some light on. Now, they brought a bunch of experiments with them, including this piece of gear right here. Here's a close-up. This is called an LLR, which stands for Lunar Laser Ranging. It's a special kind of reflector that allows scientists on Earth to fire a laser at the moon, and if you hit one of these things, there's multiple of them. Apollo 11, 14, and 15 placed these up there, and the Soviet Union put a couple of their own in sort of a different fashion. But anyway, if you fire a laser from here and happen to hit one of them, which is difficult, but we can do this, the laser light bounces back to us. We can then measure, measure how long the trip took. And that tells us exactly how far away the moon was at that moment in time. And this is still being done, by the way. It's the only Apollo era experiment that's still going on. So we've been taking very accurate measurements of the moon's distance for 40 some odd years now. And it turns out that the moon is actually moving away from us over time. Now, we're not talking about much. It's like 3.8 centimeters, so this far on average per year. But when you do the math over billions of years, it gets very interesting because the rate of recession would have been higher in the past. And I should also mention this wasn't a surprise. People expected this to be happening. What we didn't know was how quickly it was happening. And so this equipment has allowed us to measure that. So why is it happening? I'm going to take a moment to explain this, and if this is too technical and you don't get it, don't worry about it. But for people who are curious, we have shown here the moon rotating the Earth, or revolving around the Earth, which takes almost a month. What's not shown here is that the Earth is spinning on its axis once every 24 hours, once per day. So the Earth spins around about 30 times, almost 30 times, for every revolution that the moon makes. Now, this here is a bulge in the Earth's oceans. That represents the tidal bulge. So tides aren't actually that the water comes in and comes out. What's actually happening is you're on the Earth's surface, you rotate into an area of tidal bulging, and then you rotate back out of it. So we experience that as tides, but that's what's really happening. So the moon's gravity pulls the ocean toward it and makes this bulge. But meanwhile, the Earth is spinning underneath the bulge, and there's a bit of friction between the ocean bottoms and the water. That pulls the bulge slightly forward relative to the moon, which means the bulge is offset slightly, which means it exerts its own gravitational pull on the moon, which accelerates the moon, pulls it forward in its orbit, and thus the moon moves farther away. Now, I probably lost most people in the room. But the reason I'm explaining all that is because if you're curious, that's why it's happening. The point is, we understood this would be happening, but we didn't know how long or how quickly this was occurring. Now, due to this experiment, we know how quickly it's happening. But now is where it gets interesting, because if you take today's recession rate and multiply it backwards through time, well, if the moon's moving farther away every year now, looking back in time, it used to be closer to us, right? Turns out 1.5 billion years ago, it would have been touching the Earth, the way this works. Now, that doesn't mean the moon is 1.5 billion years old. That's a maximum age for the system. I mean, 10,000, 6,000 years works just fine. The 6,000-year-old moon hasn't moved all that much. But if you're gonna try to buy into the billions of years thing, you get a moon that's touching the Earth just 1.5 billion years ago. But it's supposed to be 4 billion years old. Well, that's a problem, isn't it? There's more we can say about the moon if we could take the time to do so, but for now I'll just note that the moon is, as the Bible says, the lesser light to rule the night, and it fulfills its God-given purposes quite well. It is uniquely designed for us. Moving outwards in the solar system, we have the planet Mars. Now, Mars is a rocky desert, rather cold and very dry. It has 2 moons, Phobos and Deimos, or Deimos, depending on how you pronounce that. And for various reasons, they shouldn't be there. They're very weird little objects. Their orbits don't match this whole gas cloud model, which creates a problem. And when there's a problem, you need a solution, which is that Mars formed without moons, and then an asteroid came along and crashed into some stuff and made these little chunks of things left over today. Mars gets in the news frequently, though, because we're always looking for what on Mars? Life. And if you want life, you need to have water. So Here is a news article from Nature. Now, Nature is the most prestigious scientific journal in the world. This isn't from the journal, this is from their website, but same basic thing. Now, if you're a scientist and you get published in Nature, that's a big deal for your career. A little while ago, Nature published an article that said this: the wheel of Spirit hints at life on Mars. Now, Spirit is referring to this little rover here that we had on Mars at the time, and Spirit had a broken wheel. So it was actually dragging along in the soil instead of rolling along. And so that uncovered some stuff. And so Nature had this article, the Spirit's wheel hints at life on Mars. Now, if all you saw was a headline, what would you think Spirit had found? Well, some sort of evidence of life, right? Isn't that what it says? Well, here's what Spirit found. As the wheel was dragging along, this little white patch here was uncovered. This is silica, basically sand. Everybody looks underwhelmed. The reason it went like this: on Earth, silica is often associated with volcanic vents, volcanic fumaroles. And on Earth, there's often bacteria that live in volcanic vents. Therefore, this is hints of life on Mars. I'm not making this up. This is what the article said. And this is the most prestigious scientific website in the world. Now, I'm not trying to beat up on it. Well, I guess I am trying to beat up on them. But my point is, this is the quality of science education today. The public is being told absolute rubbish. Okay, you found some sand on Mars. That's very interesting geologically, but it's not hints of life, guys. Come on. Let's stop overselling your case. Well, they don't have a case to sell, so I guess overselling is going to happen by definition. But of course, we're also constantly hearing about water on Mars. And they'll find some discovery and they'll argue about whether or not this indicates water and so on. In fact, you might be aware that planetary scientists frequently talk about an entire global ocean on Mars. And they want the ocean to be there for various reasons. And of course, where there's water, there must be life, right? Which is a total fallacy, as we talked about earlier this morning. Nevertheless, they are always excitedly talking about the possibility of there being water on Mars. What's the problem? Well, is there water on Mars today? No. Could you have liquid water on Mars today? No. Why not? Mars has a very thin atmosphere, and so the boiling point of water is very low. So even if you poured out a puddle of water on a Mars' surface, assuming it didn't just freeze because of the temperature, it would boil away very rapidly, even though the temperature there is very cold. So liquid water is physically impossible to stay on the surface of Mars for any length of time today. Yet secular modelers want there to have been a global ocean. Well, this creates a problem. Well, there's a problem, you need a solution. Well, the solution is that there used to be liquid water on Mars, which means the atmosphere used to be a lot thicker. Of course, it's not thick today, so what happened? Well, apparently an asteroid came along, crashed into the planet, changed some things around, and now Mars lost its atmosphere. That explains why there's no longer water possible there now. Now, this is interesting. Think about this. We have the planet Earth and the planet Mars, and this is not to scale, by the way. Mars is much smaller than Earth. Now, Earth has a surface that's 70% covered with liquid water. Mars is a desert planet where it's physically impossible to have liquid water on the surface today. Yet we are told that there was no global flood on Earth, because that's unscientific and impossible, but yet there used to be a global flood on Mars. Anybody see some hypocrisy going on here? Okay, moving outwards, let's talk briefly about the gas giants. So we have Jupiter, Saturn, Uranus, and Neptune, and here's Earth to scale. So you see these are all much bigger than Earth. The biggest planet in the solar system is Jupiter, sometimes called the king of the planets, famous for its giant red spot, this giant storm system that's been going on for as long as we've had telescopes to look at it. This storm system alone is bigger than our entire planet. You can imagine how violent, imagine a hurricane bigger than the Earth. What would that be like? Now, if you're going to make something this big in your model, you need a lot of stuff, right? You need a lot of material to work with. Now, we've already talked about the fact that the secular modeler doesn't have the building blocks he needs to make anything in his model. As this author here said, how this process, this planet building process, continues from meter-sized boulders, remember this is as big as they get, to kilometer-scale planetesimals is a major unsolved problem. Boulders are expected to stick together poorly. That's the problem I told you about earlier. Now, here's a second problem I didn't tell you about yet. And they will spiral into the protostar, the sun that's forming in the middle, in a few hundred orbits owing to a headwind from the slower rotating gas. What does this mean? Well, actually, back up a minute. As Jupiter is supposedly forming in this gas cloud, it's moving through gas, right? Well, that means it's plowing into the gas as it goes. That's like a headwind, which is going to slow Jupiter down as it's trying to form. So even if you could get your rocks bigger than this to make stuff from like they need, that still doesn't get you off the hook here, because as the planet is building, I mean, Jupiter as a planet is still subject to laws of physics, right? It's slowing down as it moves through the cloud. Well, in orbits, when you slow down, you move toward the thing you're orbiting. In this case, Jupiter would actually spiral all the way into the sun in how long? A few hundred orbits. A few hundred or a few thousand years. That's a really short time, given their millions and billions of years ways of thinking, right? So Jupiter shouldn't be there. Yet there it is. And oh, by the way, we've also discovered Jupiter has some important chemical differences between what is there on the planet and what these alleged planetesimals would have. And a more recent discovery is that Jupiter's core is a lot different than previously thought, and on it goes. There's been a lot of surprises about Jupiter that doesn't match any of the expectations that were being promoted for it. So he asked the question, where did Jupiter come from? As this author said, Jupiter is the largest of all the planets, but results published in Nature, the scientific journal, now reveal the embarrassing fact that we know next to nothing about how or where it formed. Who heard about this the last planetarium show you went to, or the last TV program you watched on science or whatever? As this author said, I don't think the existence of Jupiter would be predicted if it weren't observed. So, not only do you have, let me back up a minute. So we talked about no building blocks, no planetesimals first of all, no building blocks, and then the issue that Jupiter, as it's forming in the gas cloud, will migrate, is what this issue is called, as it moves through this cloud of gas. So you can't get rocks this big. If the rocks were bigger, they'd spiral into the sun. And then even once the planet forms, the planet as a whole will migrate all the way in. As this press release here from Astronomy and Astrophysics points out, theories predict that the giant protoplanets, the planets that are trying to form, will merge into the central star. That's a nice way of saying crash into the sun before planets have time to form. This makes it very difficult to understand how they can form at all. Understanding the formation of giant planets is currently one of the major challenges for astronomers. Well, it's more than a major challenge, guys. The model says the planet shouldn't be there, but there it is, which is rather inconvenient. Jupiter also has a lot of surprises in its moons, but for my purposes today and time constraints, I'm going to move on. And we'll talk briefly about Saturn. Saturn, of course, is famous for its beautiful rings. Now, the rings aren't solid things. They're actually belts of particles all orbiting the planet together. How old are Saturn's rings, though? Well, it used to be said that they formed at the same time the planet did, because there's not really a good way to make them after the planet formed. Problem is, recent results have shown they can't actually be old. For one thing, the rings are very bright. I mean, that's how we can see them. Well, as Saturn moves through space, the rings should darken over time because there's dust and other material accumulating within them. And so recent discoveries from the Cassini mission have shown we've measured how much material is coming into the rings, and it turns out that is actually inconsistent with the ring being old. This influx is actually about 10 times higher than was previously thought, and so as this physicist points out, our measurement's the most direct way you can measure the age of the rings. There's not much you can do about it. It has to be young. Well, if it has to be young, then it can't be old, which means the rings didn't form at the same time Saturn supposedly did from the cloud of gas, which means where'd the rings come from then? Well, this creates a problem, doesn't it? And when there's a problem, you need a solution, which is that asteroids came in fairly recently, smashed together, and all the particles formed the rings that we see today. Anybody detecting a trend in some of these explanations, by the way? Okay. As a planet, Saturn has additional problems. It, too, suffers from the migration problem. It, too, even if you could get the rocks big enough for the planet to form, it, too, would spiral all the way into the sun before it had time to finish forming. It, too, along with Jupiter, shouldn't actually be there, but there it is. Saturn has dozens of moons, some of which are really interesting. Let's talk about just two of them. This is Enceladus, which is a pretty little moon. It's actually the brightest object in the solar system because it reflects the most sunlight back into space. And our first photographs of Enceladus were kind of intriguing. These are Saturn's rings right here. It looked almost edge-on from the spacecraft. Here's Enceladus, and hopefully it's dark enough in here. You see there's a little smudge down here. We said, what's going on there? Let's take some closer pictures. Turns out Enceladus has geysers of water and ice coming out of its south pole. Now, this is interesting. First of all, there's a lot of material coming out. One of the rings of Saturn, by the way, it is now believed, is formed by Enceladus doing this. Enceladus is making a ring of Saturn. It's also spray painting some of its neighboring moons. They're brighter than they otherwise would be because of the ice and snow coming out of Enceladus. Now, this is interesting because Enceladus is not a big object, which means it would have cooled off from its formation long ago if it had formed billions of years ago, like the secular folks say. So if it had formed billions of years ago, it would have cooled off billions of years ago, which means it couldn't be geologically active anymore. Yet it is obviously geologically active. Here's a colorized photo added to see how much material is coming out of this little moon. Now, if Enceladus is thousands of years old, this makes perfect sense. It's still cooling off after its creation thousands of years ago. So it can still have the energy to be geologically active, which it is. So thousands of years old, not a problem. Billions of years old, well, that's a problem. So now all the secular modelers can do here is appeal to tidal flexing, where Enceladus is caught in a gravitational tug-of-war between Saturn on one side and some of the moons on the other, and so Enceladus is getting flexed and squeezed. And that does impart a little energy into Enceladus, but it's only a couple of percent necessary to account for this. So this is a complete mystery if you want to believe in the billions of years. Shouldn't be happening, but it is. Titan is the largest moon of Saturn, and as you can guess by the name, is rather large. It's actually bigger than the planet Mercury. Titan, as you can see, looks fuzzy. This isn't a bad photo. It actually looks that way. That's because Titan has an atmosphere. It's a moon with an atmosphere. Now, the atmosphere is opaque, so we can't see through it from here, from Earth, but we can see the sunlight bouncing off of Titan and coming back to us. So it's been known for a long time that Titan's atmosphere has a lot of methane in it. Why is that important? Because sunlight breaks methane down into ethane and some other chemicals. And you can show that all the methane in Titan will be gone after just 10 million years. Now, 10 million years is a long time, don't get me wrong. But Titan is supposed to be 4.6 billion years old. That's 4,600 million. So, if Titan were really that old, it would have lost all of its methane 4.59 billion years ago. But there's still methane there today. Secular modeler said, no problem, here's what's happening. Obviously, there's some source of methane way down deep on Titan's surface that's been replenishing the atmosphere with all this methane for billions of years. But that also implies that after all these billions of years of methane being broken down, there's lots and lots of ethane also built up on the surface as byproducts. Now, Titan, being as far out as it is, would be very cold. So on the surface, methane and ethane would be liquid. So based on their billions of years outlook, secular modelers said, before we got there, Titan should have a global ocean, a kilometer or so deep, of methane and ethane on Titan's surface. That's the prediction based on the billions of years. Problem is when the Cassini spacecraft got there and sent down the Huygens lander, well, the lander went down and landed on a dry surface. No global ocean of methane, no global ocean of ethane, just a sandy textured surface. Now, if Titan's just thousands of years old, this makes perfect sense. There hasn't been enough time to break down methane in the atmosphere significantly. There hasn't been enough time to build up ethane on the surface significantly. So thousands of years, not a problem. Billions of years is a problem. Moving outwards, we have the planet Uranus. Now, Uranus, as you can see, doesn't look very exciting from here. In a telescope, it's like a little blue dot. And even from Hubble or something, you can't tell much. It's fairly featureless. But when our spacecraft got there, there was a big surprise. Turns out that Uranus rolls along on its side rather than spinning like a top. So whereas all the other planets spin like tops as they go around the sun, Uranus rolls along sideways like a ball. This colorized photo here, this is one of the poles. So there's no North Pole up here and South Pole down here. This is, what do you want to call that, north or south? I mean, take your pick, right? And then the other pole's on the opposite side. Problem, that whole gas cloud thing has to have the planets spinning like tops as they come out of that gas cloud. So Uranus shouldn't be like this, but it is. This creates a problem. Well, there's a problem, you need a solution, which is that Uranus formed the right way, spinning like a top, but then something the size of Earth crashed into it and knocked it over, thus it's spinning along sideways today. Problem is there's evidence against that having happened. Number one, Uranus's orbit is almost perfectly circular. Number two, Uranus has a nice system of moons that apparently wasn't disrupted by this massive collision. On and on it goes. Uranus doesn't look like this happened, but they still say this happened because otherwise their model would have even more problems than it does otherwise. I'm going to skip some of this. Uranus also has this little moon called Miranda. Now, this is a tiny, tiny little thing, only about 300 miles across. Now, I sometimes wonder if the Lord did this on purpose just to give headaches to the people trying to deny that he's behind it all, because how many different kinds of terrain can you identify in this little thing? I mean, it looks like a patchwork quilt almost. And there's parts of it that looks like someone took a giant paintbrush and swiped it across the surface. It's got the highest cliff in the solar system, over 3 miles high. I mean, imagine standing on the edge and looking down at that. Now, pity the poor secular modeler who has to come up with an explanation for how this got there by natural processes. I mean, look how distinct, a patchwork quilt, right? Look how distinct the various edges of these things are. Plus, there's this big check mark right in the middle of it. As if he said, ha, let him try to explain this one. So this creates a problem for secular modelers. And when there's a problem, you need, say it with me now, a solution. Exactly. Secular modelers say that Miranda formed looking more realistic, more normal-like, and then a collision happened, but other people said, you know, one collision isn't going to do it. So some people are proposing up to 5 collisions in a row. So collision, break up into pieces, reform, collision, break up into pieces, reform, 5 times in a row. Other people, though, point out, you know, how do you maintain such rugged topography through even one collision and reformation after? It doesn't look like that. So Miranda's a real head-scratcher. Moving onwards, planet Neptune. We're now the furthest planet out from the solar system. It takes sunlight about 4 hours to reach Neptune. If you were on Neptune, the sun doesn't look like much more than a star, really. So people said, you know, Neptune's 4.5 billion years old, doesn't get much solar radiation. It's probably old, cold, and dead by now. Turns out it's none of the above. Despite being 30 times as far away from the sun as the Earth is, it's not, well, it is cold, but it's radiating back into space twice as much energy as it's getting from the sun. It's also not dead. We've seen major storm systems form and disappear just in the last few decades. It has the most violent winds in the solar system, 1,300 miles per hour. Hard to imagine, really. But one of the biggest problems Neptune poses for the secular folks is this. It doesn't actually exist, according to the secular model. Here's a quote from Astronomy magazine. Psst. Astronomers who model the formation of the solar system have kept a dirty little secret. Uranus and Neptune don't exist. At least computer simulations have never explained how planets as big as the 2 gas giants could form so far from the sun. And it goes on to talk about how you need 10 billion years of gathering planetesimals out in that part of the solar system before a planet is even possible. And even with their long-age assumptions, they have less than 5 to work with. So they're still 5.5 billion years short of the time in their model to explain how planets could form. And by the way, there's no planetesimals out there anyway to make anything from. You would think this would be a problem then. As this author said, it's clear that our level of sophistication of studying planet formation is relatively primitive. So far, it's been very difficult for anybody to come up with a scenario that actually produces Uranus and Neptune. And I like this phrase, come up with a scenario. This is really the heart of a lot of what goes on in the creation evolution discussion. The goal of the evolutionist is to come up with a story about how something could have got there without a creator. And oftentimes they seem to believe that just the mere act of coming up with a story proves it actually happened that way, which of course is another logical fallacy, right? Now the reason I give the solar system talk is to show that it doesn't even have to be a good story. I mean, think about it. If your job was to come up with a story for how the solar system and the planets got there, could you do a worse job than to come up with a story that says the planet shouldn't exist at all? But that's what the story says, right? Even with its implications. Yet they're still proclaiming this model as being true. Rather than acknowledge the creator, secular scientists would rather cling to a story that denies the very objects it's supposed to explain. This is not a scientific issue. This is a spiritual issue. The heart of man is desperately and foolishly wicked, right? Desperately wicked and foolish, I should say. So it's not that they have all this evidence for denying the creator, it's that they want to deny the creator, and they'll grasp onto the best evidence they can get, even if best isn't good at all. More recent example of this is Pluto. Yes, I am going to talk about Pluto, even if it's not a planet anymore. Pluto had all sorts of cool stuff that we found here, just recently when the New Horizons spacecraft went by it. It blew everybody's socks off, figuratively. Pluto had really interesting terrain on the surface. For example, you see there's large, smooth areas, large regions of smooth, craterless terrain. Now, that's interesting because other parts of Pluto do have craters, like over here. So you see craters over here, smooth over here, and then in the middle, there appears to be some craters that are partially filled in. So it looks like Pluto had craters, and then in large parts of it, the craters have been filled in by something. The surface of Pluto has been reworked, and it's very recently that this happened. Why is that? Because there's no craters on the smooth stuff. There hasn't been time for new craters to form. I mean, this could have happened the day before the spacecraft got there, for all we can tell. Thank you. Now, this is interesting because Pluto is not a large object, tiny little thing, and we've talked about this reasoning before. If it's a small thing that formed 4.5 billion years ago, it would have cooled off billions of years ago. It can't have energy to be geologically active anymore, but it is still geologically active. Thousands of years works just fine. It's still cooling off from its creation. It can be geologically active. Yet the billions of years doesn't work at all. Nevertheless, even with problems like this, what gets questioned? Are people finally going to question their billions of years assumptions? Here's a quote that came out after the Pluto discoveries. The scientist said, every time we looked at a body that has experienced tidal heating, such as Io and Europa, I didn't have time to talk about these, and Enceladus, this is the one with the fountains, remember? We found that the body's been more active or putting out 10 to 100 times the heat predicted by models. So these things are too hot. They're geologically active where they shouldn't be after billions of years. But do they question the billions of years? No. Here's what they question. Enceladus taught us that our models of tidal heating were not right. And I think the Pluto-Charon system could be telling us something similar. So rather than question the billions of years, they're questioning their understanding of how heating works. They'll question physics before they question the billions of years. Now, I'm not claiming a conspiracy to lie to people. I'm pointing out how thoroughly indoctrinated the secular community has been with this billions of years thinking. They'll question how heating works before they'll question the billions of years. And running short on time here, so skip a little bit. Let's talk briefly about comets. I mentioned them earlier. Comets tell us a few interesting things about the age of the solar system also. I mentioned earlier comets are basically dirty snowballs flying through space. This is the Wild 2 comet. It's about 3 miles across, so that gives you an idea how big they are. And for most of their lifespan, if you will, comets aren't very exciting because they're dirty, so they're dark. They're small and they're far away, so we can't see them. But as they get closer to the sun in their orbit, sunlight heats them up, and the ices within them starts to sublimate into gas. The gas comes out as jets, and then that forms the beautiful tails. Sometimes they're beautiful, sometimes they're not. It forms the tails that we see from Earth. Now, this is interesting because that means every time a comet approaches the sun, it's losing material, right? And that means every comet you see is eventually doomed to destruction. Some of them won't stay in orbit. Some of them will get flung out completely and leave, never to return. But the ones that do stay in orbit will actually eventually break up into pieces. And we've actually seen this happen with a few dozen comets now. How long would this take? Well, some types of comets, called short-period comets, orbit the sun in a short enough time, less than 200 years, that you can calculate they would last only about 10,000 years at most before being gone. Now, this is interesting because the secular model can only account for comet formation at the very beginning when the gas cloud was still around. So that means these things are supposed to be 4.5 billion years old, but yet they only last 10,000 years, and we still see them today. This is an argument for a young solar system. We still see things that can only last for a few thousand years. That means the solar system itself is only a few thousand years old, right? Now, secular modelers do have, they think, ways to keep these preserved for billions of years and then periodically replenish the supply. Those explanations don't work. If you're curious about that, you can come talk to me later. I won't take the time to talk about it today, or right now, rather. So what's the bottom line of all this? As one of my astrophysics textbooks says, thus far we have seen that we know very little about the development of the solar system. As this author said, to sum up, I think that all suggested accounts of the origin of the solar system are subject to serious objections. The conclusion in the present state of the subject would be that the system cannot exist. Well, it does exist, guys. That's because your gas model is wrong. Your billions of years are wrong. The heavens declare the glory of God who created all of these things, and the firmament shows the work of his hands. So obviously I've presented a rather different perspective on astronomy to you today than what you would usually get in a planetarium or Cosmos TV program or what have you. I have a free email newsletter that's available to you. I'll show you my website in just a moment where the sign-up is. You won't get spammed to death, but just as things are announced, typically they're saying, hey, we found such and such, but there's more information that they tend to leave out. Well, my newsletter is to give you the rest of the information that they're leaving out.